Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adrian Azmili bin Abdullah. I'm from Group 12 and I will do the part for introduction. So, I will talk about atomic theory of matter. So, basically, matter exists in three states. There is solid, liquid, and gas. The state of matter actually is determined by the strength of the bonds between the atom that makes up matter. So, for example, solid is stronger than liquid. So, to change from one state of matter to another is called a phase transition. For example, an ice cube melt down into liquid as energy is added. And for another example is when the waters evaporate into gases. Instead of matter, solid, the particles vibrate in place and tightly packed, therefore the speed of particles are slow. When they get hit, they vibrate each other, they did not move out of their place, so they are stay together. They are bound to be together. And for the liquids, their particles are close but still can slide past another, therefore the speed of particles are medium, more faster than solid. And the last one is for the gas. Their particles are constantly expanding, therefore the speed of particles are faster than solid and liquid. So for the next topic, I will let my next friend to present. That's all for me, thank you.
Okay, hi, I will explain about Boyle's law. Okay, so Boyle's law is introduced by Robert Boyle. Boyle's law stated that the volume of a gas is inversely proportional to the absolute pressure applied to it when the temperature is kept constant. Okay, so in this law, we need to remember that the temperature is remain constant. So, it is a relation concerning the compression and expansion of a gas at a constant temperature. The law can be derived from the kinetic theory of gases, assuming a perfect ideal gas. Okay, so this is the equation, which is P1V1 equal to P2V2, shows that as volume increase, the pressure of the gas decrease in proportion. Similarly, as the volume decrease, the pressure of the gas increase. So Boyle's law is often used as a part of an explanation on how the breathing system works in the human body. This commonly involves explaining how the lung volume may be increased or decreased and thereby cause relatively lower or higher in pressure within them, in keeping with Boyle's law. This form of pressure difference between the air inside the lungs and the environmental air pressure, which in turn precipitates either inhalation or exhalation as air move from high pressure to the low pressure. So this is one of the application that we can see in this Boyle's law.
Hello, Assalamualaikum. My name is Abdul Fatah Alimi Badullah, and today I'm gonna present about Charles law. So, Charles law was discovered by Jacques Charles in 1802. He discovered that the volume of a gas at constant pressure is directly proportional to the absolute temperature of the gas. So, this is the formula. V is proportional to T, or V over T equals to constant, or we know as K. And yes, thus this made that V initial over T initial equals to V final over T final. So this is the graph of Charles law to explain the Charles law. We can see that the slope or the gradient is always increase. When the temperature increase, the volume also increase. So this explains how Charles law works. So that's all from me. Thank you.
So next, I'm going to talk about Gay-Lussac's law. So Gay-Lussac's law stated that pressure and temperature are directly proportional. So what does it mean? It means that when the temperature is increased, the pressure will be increased too. So how does it work? So let's say if I have a container that's full of water and have constant volume. So if I add heat to it, the temperature will be increased. So the molecule in the water will gain kinetic energy. So they will be moving a lot more faster at a very high temperature. So this situation will cause an increase of speed, and they will collide more frequently with each other and with the wall of the container. So as a result, the number of collision will be increased, and then the pressure will be increased too. So this is how it works. Same goes if I want to cool down the temperature of the container. Let's say if I put ice under it, the temperature will be decreased. So the molecule, the water molecule, will lose their kinetic energy. So they will be moving a lot more slower. So the number of collision will be decreased, and then the pressure will be decreased too. So that's what the Gay-Lussac law is, that the pressure and temperature are directly proportional.